On? You said we're doing on? Cool.
And you're live. And Christian, it's the floor is yours.
Okay, very good. Thank you for coming by and observing the third installation of Istio in the real world. We'll be talking about using Istio today to secure your service-to-service communication. And my name is Christian Posta. I'm a field CTO at a startup called solo.io, where we build service mesh tooling to help people be successful with service mesh adoption. And with me today, we have Sandip. Sandip, you want to introduce yourself?
Yeah, thanks, Christian. Hey, folks, my name is Sandip Parekh. I am a Anthos developer advocate for Google Cloud, and I focus on Istio and service mesh area in general.
Take it away.
Perfect. So with that, why don't we get started? So today, what we're going to cover, we've got 5 main areas we want to talk through. So one, what are some of the challenges around securing microservices deployments? Why does Istio make sense as an option there? What are some of the actual specific solutions that Istio offers? And we'll talk a little bit about what's available in the ecosystem as well. We're going to close with a little bit of what else is new in 1.4 and tease a little bit of what's coming in 1.5. And then we've got time for questions as well. So if you've got questions, please drop them in the chat and we'll try to get through them. If we can't answer them during this session, we will try to follow up as best as possible. So let's start with challenges. When we think about securing microservices deployments, one of the clearest requirements that comes up quite a bit, and we've heard a lot in the ecosystem of Kubernetes users, is how to properly secure service-to-service communication. So what that typically means is, how do you encrypt traffic between your services? Now, when you're running in a typical Kubernetes deployment, services are always communicating using plain text, right? Everything from ingress into your services, all the services you're communicating with, they're always going to use plain text by default. Now, if you want to secure communication channels, it's certainly possible to do that and to create your own mechanism to do so, but it does require a few things that are really important. One, your applications have to be updated, right? So you've got to include encryption support in your application in some meaningful way, either compiling in libraries or including external functionality and building that into your application and regenerating that container image. So your applications have to understand how to use encryption and how to work with it. And the other part of this, and this is the part I think people forget about, is that you've also got to have a separate piece of infrastructure within your deployment somewhere, whether running in Kubernetes or otherwise, that's going to be able to hand out those keys, right? In order for services to use encryption effectively and properly and to have, you know, a trusted kind of key distribution and certificate authority for handing out those keys and generating them, you've got to have some other infrastructure to generate and supply those things across your services that are running. Which leads us to typical challenges people run into. So the first one, I think, is pretty straightforward, right? We have to update applications to include encryption support. We talked about that. The second one is really the one where we found folks get really, really lost in, right? This is a hard problem, creating a distributed system to provision and manage those keys and also do things like rotate them, make sure the root and the certificate authority is a trusted chain. So there's quite a bit of work to make that all sort of fit together and do it in a scalable fashion. And then the last one, I think, is another area that people forget about is you may have legacy applications that can't be updated, right? That may be running in containers and maybe running in pods within your environment, but they might not be able to pick up encryption support for a variety of reasons, right? There are lots of reasons why it might not be able to be done. So now your applications have to be aware and understand that some of the sources that they're going to communicate with might not support encryption. So this adds just a lot of cognitive overhead when you're deploying these things. But the second big area we see from a security perspective is how to control access to services, right? And this is typically like an authorization model in many cases. Now, if you wanted to prevent unauthorized access, like in the diagram here on the right, service A can talk to service B, B can talk to C, but A cannot talk to C. So how would we typically implement that with Kubernetes, right, as a starting point. The good news is that with something like service accounts and Kubernetes and RBAC, so Kubernetes service accounts plus RBAC gives you some of this capability, but it's relatively coarse-grained, right? It's really just talking about service-to-service access. For a lot of deployments, they need something a little bit more fine-grained than that. So there are two aspects here. One, they want to better understand service identity and potential user level identity, right? You want to be able to pass in user level authorization credentials all the way to that service running in your deployment. But the other part of this is that you may want to have, again, a finer grained level of control. So you may want to say things like, well, service A can access a specific route and a verb combination from service B, right? So you might say, I only want to allow the get method to this particular URL on service B, or if it's a gRPC application, you may only want to allow access to a particular package path, and again, a particular verb associated with that. So it's not simple enough, it's not easy enough to just say, we'll lock down access just based on service level granularity. We may want to get down to kind of host and path and verb level granularity. To implement this does, again, introduce a series of challenges. So one, applications need to either compile and support or build in support in some meaningful way to understand and verify service and user identity, potentially in every single call, right? If you want to get to that fine-grained level. And then on top of that, applications need to apply those identity controls to every potential route or endpoint / verb combination, right? So every URL that you may expose, every route, along with every possible HTTP verb, for HTTP connections, that can become, again, adds a lot of cognitive overhead. Now, in a small scale scenario, this isn't terribly difficult. There are ways to do it. But if you think about this problem extending to hundreds or thousands of microservices, it becomes very, very challenging very quickly. And so that's what we're left with as far as what some of these challenges are when either securing communication or implementing some kind of authorized access. So now let's talk a little bit about why you would choose Istio to help solve this problem. So before, I think Service Mesh and Istio specifically came along, when applications running in Kubernetes environments wanted to kind of take on some advanced functionality. And frankly, what we find is enterprise functionality that folks really want to have as they, again, go bigger, right? So don't think of this as 1, 2, 3, 4, 5 microservices. Think of this as tens, hundreds, or even thousands of microservices. When you want to include things like circuit breaking or identity support, encryption or tracing, those are things you have to compile into your application or build into your application in some meaningful way. And then you still may want to have some kind of access control, ingress control, egress control. And so without Istio, these things become hard, right? These are all components you have to, again, take on the responsibility for managing or including in your applications. Once you incorporate Istio, the story changes a little bit. You have now the ability to leave your application as is, and it lives in that pod. And instead, what we do is we follow this kind of sidecar model and a control plane approach, where the sidecar is there to sort of mediate all inbound and outbound network traffic. And by mediating all that, once it's paired with a control plane, the control plane can actually instruct the sidecar on how to do things like circuit breaking or fault injection. It can handle some of the aspects around identity or encryption. And because it's mediating all that in and outbound connectivity, you've gotten a window into observability, so tracing, logging, and metrics data almost immediately. And that control plane also does a lot of heavy lifting, right? It also implements ingress and egress controls. It has a certificate authority built into it, and you can use a kind of a simplified API to implement access control or routing rules. So this adds quite a bit, again, and it's outside the bounds of the application. So it makes it a lot easier for apps to pick up the support relatively quickly. From a security perspective, if we dive a little bit into Istio security architecture, and we're not going to spend too much time on this slide because it's quite a bit going on, but the point really is that there is a clear sort of understanding here that these policies can be implemented at different levels of granularity, right? Down to the individual service, up to like the namespace level, or even across the entire mesh. And identity can pass throughout here for all of your services, as well as we can encrypt with MTLS. There's authorization controls, there's support for things like JWT tokens or OIDC as an identity mechanism. So there's quite a bit that's encompassed here. And we're going to simplify a little bit here and kind of focus on two specific areas. But this is just to give you a quick glance at what's possible if you sort of expand out the entirety of Istio security capabilities. So now some of the solutions, and starting with some of the ecosystem aspects of it, frankly, what we found is it's hard, right? Securing communications is a hard task to do, and there's lots of work on securing connectivity between ingress and pods, right? So you can imagine like securing ingress right at the front end with things like cert manager, or even securing sort of external load balancer to ingress mechanisms. But once you enter in that Kubernetes deployment, there isn't as much that isn't sort of bespoke or custom, right? And the same thing applies to incorporating identity. Folks use Kubernetes service accounts as much as possible, and that's great. It's a very powerful mechanism for establishing service identity. But again, user identity ends up being more bespoke or depends on a lot of custom integration. And this is where service mesh, and again, specifically Istio, tends to shine quite a bit because it provides these capabilities in a relatively turnkey fashion. So let's talk about the first pass here, which is encrypting service traffic using Istio. So when you want to enable MTLS authentication, there's two main API components you have to worry about. One is the policy object, and the second is the destination rule object. And a policy object tells services what sorts of connections they can accept. And a destination rule object tells clients of that service what sorts of connections they should use. So in this case, if we apply a policy that says strict, and we're telling services they can only accept strictly MTLS connections, and now we've got to make sure to do the other half of that and make sure we tell clients that clients of service A can only accept MTLS connections, so you must use mutual authentication. And that's the typical process for rolling out MTLS authentication. The upside of this approach is that it allows us to take this idea of securing a subset of services and rolling MTLS out slowly across a deployment. The benefit here is that if you have services that for whatever reason may not be able to adopt MTLS, maybe there are enterprise requirements, maybe those services, like in a legacy namespace, can't communicate with other upstream or downstream services using MTLS for, again, requirements that we may not have access to, but those are real enterprise scenarios. So we want to be able to incorporate and leverage MTLS without cutting off access to legacy services. So the way we typically do that, so here in this example deployment, I've got two namespaces, one's called legacy and one's called secure. In the secure namespace, I've got Istio injection enabled. So front end and back end have the sidecar proxy already included in their pods. And then what we can do is, from a starting point, we can actually implement a policy object in the secure namespace that just tells backend to accept connections from anyone, right? So we're setting up to be permissive, which means it can accept connections that are not authenticated. So this way, service is still able to communicate with backend. And then we can actually use a destination rule with Istio Mutual and tell clients of backend that they can use Istio Mutual if they can present it. So now what's happening here is that the service in the legacy namespace is still using plain text, but front end is communicating to back end using mutual TLS. And so now we've got this kind of mixed mode deployment. And now if we want to sort of complete the cycle and say, now we're going to cut off access to all legacy clients, the final step is to update that existing policy object and change the MTLS mode to strict. So now anyone that tries to communicate over plain text is going to get rejected. And the front end and back end connections are still secured with MTLS. And this is typically the process we see, again, with enterprises rolling out support for this, because they want to leverage encryption, but they've got to manage its rollout over time. Now, what's really nice is that new in Istio 1.4, there is support for something called Auto MTLS in alpha. Auto MTLS is very powerful because right out the gate, Istio sidecars automatically know to use MTLS connections unless you actually specifically deactivate it. And you can enable strict connections across the board for all clients, right? So any legacy clients would no longer be able to connect using one single policy object. So we've taken out the hard requirement of using two mechanisms, policy and destination rule, to control it. Now with Auto MTLS, one, it's on by sort of default in the background for clients that can do it. And then when we want to strictly allow access only to MTLS capable mechanisms, we can do it with a single policy object. And of course, it can be overridden by destination rule objects as needed. The key here is that this behavior is an option that you have to turn on at install time. So it's a mesh-wide install flag, and you can see on the middle line here, we're setting values.global.mtls.auto equal to true. And that's going to turn on this automatic support. I would strongly recommend that for anyone who's really interested in this feature, one, to go test it out, and two, there is some active discussion within the community about making this automatic MTLS option a default instead of optional. There is a GitHub issue linked on the Auto MTLS page on the Istio docs. Again, if you're interested in using this feature, I would strongly recommend you comment in that issue and let us know if this is a feature you want to have out of the box, because we think it's really powerful, and we see a lot of folks adopting service mesh and specifically Istio for its MTLS capabilities. So we want to understand if there's enough community support for making this an out of the box, default, as opposed to an install time option. So that was a little bit around encryption. Now let's talk about authorizing service access. So if you remember before, we talked about Kubernetes service accounts being the part that establishes service identity and needing, more than what RBAC provides. So before Istio 1.4, there were 4 components you needed to really implement authorization. Obviously, one is that service account I just talked about, which is a Kubernetes primitive. And then we needed 3 Istio mechanisms. The first was cluster RBAC config. This was a mechanism that actually, an API object that turned on Istio RBAC across the entire deployment. And you were able to do things like which namespaces to include or exclude. But then to actually set up the specific service level authorization controls, you had to create a service role and a service role binding. The challenges here is that there's a little bit of overlap between service role and service role binding, so you've got to sort of develop those in parallel. The cluster RBAC config object was not well documented in the past, and frankly, there was a lot of overhead in having to set up simple authorization with this model before Istio 1.4. One of the things that's new in 1.4 and kind of beyond is the new authorization policy object in beta. And so the first thing that it does is we're deprecating cluster RBAC config, service role, and service role binding from this point forward, and moving everything to authorization policy. But 2, we've also added support in the Istio CLI tool for automatically migrating folks using the deprecated version into the new version with a simple experimental flag. So there's an option there to sort of migrate an existing authorization deployment into the new authorization policy model. And this model is great. I love it because it simplifies a lot of what you have to do, and it puts all of the functionality you care about in a single API object. So it keeps it a lot simpler from a sort of design and implementation perspective. So now if we look at an example of this here, again, we want to sort of implement fine-grained authorization controls, right? In this case, we've got service A in the team 1 namespace and service B and service C in the team 2 namespace, and both of these namespaces have Istio injection enabled. So now let's say we want to implement the example we talked about earlier, where A can talk to B, B can talk to C, but A cannot talk to C. How would we do such a thing? So it's actually relatively simple. What we can say is that service C can only allow connections from service B. And what we use to identify service B is a Kubernetes service account. So there is a little bit of updating that has to happen here, right? If you didn't have service accounts deployed previously, you have to make sure to create those service accounts, right? In this case, we'd have to create one for service B. And we'd also have to make sure to update its pod spec or its deployment spec to incorporate the service account. But once that's in place, and that's a simple kind of rolling update approach you can do relatively easily, with a simple authorization policy object, and this is a really, really bare example, we can control, again, that service level access. Now, if we wanted to get really granular, we could add more here and say, let's add an additional principal for service A, and we can actually, again, highlight specific routes and verb combinations that are allowed for A to access C. So we could say service A can only access service C on the with a get method on just the slash, the base route. So that sort of level of control is possible here. So again, this ends up becoming a very, very powerful mechanism. Some things to remember here, and the biggest one actually is that these rules are additive. So they're not negating rules, and over time there's actually active work going on to allow negation, but right now everything's sort of additive. So as you add rules, you're adding capabilities, you're not taking them away, or you're not overriding what's already there. So that's an important thing to remember as you're trying to roll out, again, a kind of fine-grained authorization approach. Now, if we're talking about user identity authentication, I'll let Christian talk through this example.
Yeah, thanks, Sandeep. So we can also require a valid JWT token or token that identifies a user in the request before we allow a request to go through. And we can take the principles from that as well and use that in the authorization policies that Sandeep just showed. Let me share my screen and walk through a demo of this. So if we come here, the demos, we're going to show 3 demos, providing that they actually work. We're going to show the 3 different concepts that we just introduced. One is the auto MTLS for our services, which would encrypt all the traffic going between the services in the mesh automatically. And with the auto MTLS functionality, we can leave the mesh in permissive mode for those services that are not equipped to do MTLS immediately. So we can have a combination of those. And then we'll show the authorization policies that Sandeep has introduced, as well as requiring JWTs for access. So let's come here. The first thing I want to point out is that the source code for this demo is all on GitHub, and we can add this to the notes and in the comments. As part of the docs for the source code here, we see how to set up a cluster to help get started. We also see how to install Istio. And we are explicitly setting the auto MTLS flag to true and turning off MTLS once we install. And what this will do is put it into permissive mode. Now, if we want to come in, now we have, let's take a look at our cluster. We see that we have Istio installed. If we want to come in and verify that we indeed have MTLS, auto MTLS enabled, we can take a look at the Istio config map in Istio system. And if we look for auto, we can see, yep, auto MTLS is indeed on. So let's take a look at our demo here. This demo is going to be using the hipster shop from the Google Cloud microservices example. So if we refresh this, we should be able to see the main UI. If we click on the source code down here, we can see exactly where it's hosted. So you can pull down a handful of services that collaborate together to provide some functionality. So the first thing that we're going to do is check that MTLS is indeed in permissive mode. And as Sandeep mentioned, we can look at the policy object to see that, and this is what is installed out of the box, and we can see that it is in permissive mode. We come back here to some of the diagrams. So this is just a diagram of what the hipster shop looks like. What we're going to do is we saw that that auto MTLS is enabled. We saw that we are in permissive mode. Let's make sure that for services in the mesh that can do MTLS, so that's the ones with these sidecars here, that MTLS is actually enabled and enforced. So the first thing we're going to do is we can take a look at the Istio CTL tools for checking whether a service is involved in TLS. And we can see that the settings are auto and permissive. But what we're going to do is go a level deeper. We're going to pick, at random really doesn't matter, but we're going to pick the traffic that's going from the front end service to the product catalog service. So if we come back here, that would be from the front end here to the product catalog service. And we're going to verify that indeed that TLS, that encryption, that mutual TLS is enabled here. So this is the IP address of the product catalog service internally inside the mesh. What we're going to do is use TCP dump to capture the traffic between front end and the product catalog using that IP address. So on the bottom pane here, what we have is the deployment for the front end service is a quick config setting that I need to change, because by default you cannot write to the file system. We're gonna change that, because we want to be able to capture the TCP dump and the packets, the network packets going through, and save that file. We're going to save it locally on the pod there. Let's make sure that that pod has come up. It is slowly coming up. We'll give it a second. And so what we're going to do is remotely start TCP dump. We know the IP address of the product catalog service, and we're going to give it a filter to just capture the traffic when it's going to the product catalog service. So if we look here, we should have our front end service running. The other one should go away. Perfect. Now, if we come back up here, let's run the command to start the TCP dump. And we see that is happening, and it will save the output to a file in the pod called output.pcat. If I come over here and refresh and hit our front end service, some traffic should be going through the system now. If I end that, now we can take, now what we're going to do is take that pcat file and copy that over to our local disk so that we can evaluate it. We're going to take a look at it using Wireshark. So I click on Wireshark. If we do file open, look in temp, we can see our output pcat there. And if we open it, and we can see there is application data flowing between the front end and the product catalog service, but we can also see that this traffic is encrypted. Now, we didn't capture the packets as the TLS and MTLS session was being created. It looks like we captured it in between. So we don't see the handshaking, but we can see that the data is indeed encrypted. So the next thing that we want to show is the authentication or authorization policies that Sendip mentioned. And so what we're going to do to set that up is we're going to create a couple of service accounts that we'll use for authorizations. And then we'll see how, using this new API, we can block access to certain services. So come back here and look at the diagram. We can enable traffic to go from the checkout service to the currency service, but we can block traffic going from the front end to the currency service. So let's take a look at how we would do that. This is the Auth-Z policy that we'll start with. It says that if you're calling the currency service, that can only be done from a service account of checkout, which matches here. Checkout is allowed to call currency service, but we don't see any rules about the front end calling currency service. So let's go ahead and apply that. And we'll give that a second. The configuration in Envoy specifically, which is the service proxy underneath Istio and Istio in general, the configuration is eventually consistent. So it does take a second, but if we click on refresh, we should see that we could not retrieve the currencies because the front end service could not communicate with the currency service. So if we add the policy RBAC here, so that front end and checkout can call the currency service, then we should restore access here. Let's try that out. You see that configured. It's not clean up yet. I'm gonna come back here. If I refresh, cross fingers, okay, we're back. So now the front end service in this case, because of the policy access that we've allowed, can talk to the currency service, and as well as the checkout service talks to the currency service, and things proceed as we would expect. Now, the last use case that we'll look at is when a service, when you're trying to talk to a service and you want to enforce that it has a JWT token and that that token is valid. That's the last demo that we're going to, let's clean up that authorization policy real quick. The last one here is the JWT demo. And so what we're going to do is we're going to do this from the command line. What we're going to see is that when we call the front end service, we're just going to dump the headers because we want to see whether the call completes successfully or not. And we can see when we do call the front end service, it completes successfully, just like it did here in the UI. But what we're going to do here is we're going to specify a new policy that requires a valid JWT token. And that JWT token will be issued and verified using these URLs. Now, in this case, we're using the Keycloak project. I can see here in our list of pods, we have the Keycloak single sign-on service here. And we will be issuing JWT tokens from Keycloak and then using them to, and then asserting them when we call the front end service. So we're gonna apply this to front end, and we're gonna require a valid JWT token when we call front end. So let's create the policy. That looks fine. Now, if we, let's see if we can just grab the headers. It does take, like I said, a few moments for the policy and the configuration to trickle down. It will trickle down. We'll keep calling it until it does. We're expecting a 401 because our request does not have the JWT token. And we see that we're still getting 200s. I'm not that worried. I know it takes a second. This is eventual consistency in action here, folks. I won't make any database vendor jokes. Come on. Well, maybe not. Maybe this is one of the perils of a live demo. Things are taking either longer or not working at all. Oh, come on, it was working. What did I do wrong? All right, well, this one is possible. Third time's not the charm. Third demo is not the charm. Well, it's supposed to be blocking our service access here and giving us a 40. What is it doing? 401. Not though. Huh. I don't know. Well, we'll carry on, and if it happens to kick in, then we'll come back to that. So we left off with what's new, and I suppose send it. You'll take that.
Yeah, I can talk about what's new here. Give me a second to switch it on back. Oops, wrong one. There it is. All right. So we can kind of close a little bit here with what's new. So we talked about authorization policy and auto MTLS already. What else is in 1.4, which is a couple months old at this point, honestly. But due to Thanksgiving and Christmas, it's hard to kind of schedule another video. So we waited until the new year. But one of the big things is mixerless telemetry. So if y'all remember, this has been a mechanism or an announcement that's being sort of teased and slowly rolled out over the next few releases, but ultimately Mixer is going to go away. And telemetry is going to be reported directly from the sidecar, from the Istio proxy that's built on Envoy. That's going to report directly to any of the downstream metrics mechanisms, whether it's Prometheus or if you have custom integration with things like Stackdriver or Datadog. But everything's going to be mixerless. So that's a really, really important distinction because it introduces a couple things. One, ultimately, when Mixer goes away, telemetry will go and become the responsibility of the Istio proxy sidecar. But there's also another thing that Mixer was responsible for, which were doing things like custom policy checks right at the edge. And that capability is actually going to move into Envoy as well through WebAssembly filters. There's a lot more work happening in this area. There's a ton of work that actually Stella's been doing as well. So we're hoping as we get closer to 1.5 and 1.6 over time, we'll have a lot more to share. I think we should probably plan to do a video just solely focused on WebAssembly and what that means to Istio, because it's going to have a pretty big impact in a mixerless world. But that's a big thing that's starting to happen, and you can see that capability now if you want to test it out. The other one is greatly expanded Istio-CTL analyze capabilities. This was, again, a feature that was experimental back in 1.3 and is now getting more and more power. And it gives you the ability to do a few things. One is to analyze an individual Istio API object and an individual YAML file in your file system, or to analyze a bunch of files together to see how they're going to interact. Or you can actually point it to a live cluster and analyze what's there. So you have a lot of capability to understand, is something broken? So, for example, in the situation we're just dealing with, where Christian applied a policy object with JWT tokens and it wasn't picking up that change, we could have essentially used Istio-CTL analyze to sort of understand, hey, was that authorization policy written correctly but not referring to the right source, or is there a conflict somewhere with another file that we haven't seen? So there's a lot that can happen from a conflict perspective at runtime, and that's what the analyze capability in Istio-CTL can help understand. Among those as well, from improvements in 1.4, the other big area was a bunch of improvements on the sidecar. So much better graceful exiting in crash scenarios, a lot more metrics being reported, and now as well, the ability to mirror a percentage of traffic, which was really handy. So traffic mirroring is a really, really cool capability that Istio provides. So you can set up a new version of a service and just mirror traffic to it silently. It's out of the critical path. It's async on the standard request path. So you get to see how your application performs with the new version without impacting user-facing behavior. And now we can actually do it with percentage-based routing. So it gets a little bit more friendly. Instead of sending everything to that new version, which may be running in a small number of pods, to just a much smaller amount. And then we've also dropped a link into the full sort of change notes of every change that went into 1.4. But we also want to talk about what's coming in 1.5. There's only 3 bullets here, but the first one is really the most salient and the most important. Istio-D is coming. Istio-D takes the remaining control plane components, and instead of running them as a series of microservices, actually turns them back into a monolith. And I didn't get a chance to get the link here, but Christian did a great video on this, I think a couple of weeks ago, maybe. So maybe when we upload the slides to SpeakerDeck or something, we can update this with that link. But it was a great video explaining why we're making this transition in Istio, right? Why are we going back from microservices to a monolith? And in this case, it does make a lot of sense. Istio-D is a big change, but it's going to have a lot of downstream operator experience improvement, particularly around things like upgrades, right? There's a lot more that we can do as a monolith, and especially as we've taken out something like Mixer, so it's not in the critical path on every request, and now it's really just sort of Pilot and Citadel, and we can put those two things together. And that does have some other downstream impact on things like control plane security. I put a link in here to the draft release notes, which is in a Google Doc being written by the community. Christian, do you want to expand a little bit about Istio-D and talk about that for a couple minutes?
Yeah, I think Istio-D is a really good example of identifying when assumptions about your architecture didn't play out the way you expected, and reacting to that and correcting course. So the idea was, with the various Istio control plane components, they were built as a set of services that would collaborate and interact with each other to provide the functionality of the Istio control plane, essentially microservices. And the idea with microservices is to decouple software architecture points in such a way that it aligns with the organization, so that you can make changes and updates and configuration and so on independently from the other services, right? So the whole point of microservices is to enable parallelism and autonomy to be able to move faster. And what we noticed with the Istio control plane is that organizationally, those assumptions never really took hold. So when folks would take and consume Istio and run them, either a platform team, which consisted of a handful of people, or a service mesh team, which consisted of one person, they were in charge of operating the control plane, managing it, updating it, upgrading it, and so on. And they would do that as kind of a whole, right? So there wasn't this need for the decoupling in terms of organization. And in fact, it ended up causing more complexity and more confusion than was needed for that particular type of use. So IstioD just reflects that we're trying to match the operational use case, simplify the complexity where it's unneeded, and get some of the benefits of, in this case, using a monolith to operate Istio.
Cool. Thank you, Christian, for that. That was awesome. And like I said, I will absolutely update the link to these slides before we post them with a link to that video. It's very much worth watching. All right, that's it for us, folks. Thank you for your time. I think Eddie might try to help us get some questions here as well. And then we've got a bunch of links on the right there if you want to learn more about Istio, Google Cloud, Solo, Service Mesh Hub, and Glue, as well as a link at the bottom there to the GitHub repo that's got the code that we use for this demonstration.
Sandip and Christian, there's a couple of questions in the chat. One here is how to terminate TLS traffic on a sidecar.
Do you want that one? Or do you want
Christian, do you want to take that one? Yeah.
How to terminate TLS traffic on a sidecar? Is that what the question was?
Yeah. Is there a CRD-like gateway which we can apply to the sidecar?
So as we saw earlier in the presentation, the sidecar in Istio gets issued a certificate that helps identify what that service is. When the communication happens within the Istio mesh, and either the auto MTLS is enabled, or you're explicitly enabling it with the various policy and destination rule objects. So recall that the policy object configures the server side to to handle mutual TLS. Whereas the destination rule object configures the client to expect mutual TLS. So when the certificates are issued to the sidecars in the service mesh, and these configurations are appropriately set, then the Envoy proxy, which is the sidecar proxy, will be configured to expect a TLS or mutual TLS connection. And the Envoy proxy will be configured with the certificates and manage that transport security there. So the applications themselves don't have to, my background is in Java and Python and so on, but you don't have to configure key stores and trust stores and all that stuff within the JVM. That is handled at the sidecar level where the proxy is, or Envoy proxy is.
Great. Yeah, the use case that Nomster was asking is they want to replace Nginx with Envoy for TLS termination for traffic originating outside of their cluster.
Yes, and that's absolutely possible with the Istio gateway. If you want to say some words on that, Sandeep. Yeah, so in this case, if you want to terminate external connections, that termination, the way Istio is designed, happens at the Istio ingress gateway. So that connection gets terminated there, and then mutual TLS takes over to encrypt traffic between the ingress gateway and your application pods. So there isn't, as far as I know, a way to let ingress gateway be a pass-through and let your application terminate, right? It's going to terminate there with TLS and then use the Istio MTLS from that point forward from the ingress gateway on. Another, just because there's a joint Solo and Google Cloud webinar here, I just want to point out that Glue is a Solo built open source project. It also builds on Envoy and allows you to extend Istio to support edge
API gateway-like functionality. So you might need to, for example, I tried to show the chat demo, but you might need to assert a user's identity using OIDC or OAuth or API keys or some other mechanism. And Glue is a good way to solve that challenge and bridge into the rest of the Istio service mesh.
Great. That's it. That's the only question we have today, guys.
Very good. I encourage you all, if you're watching this not live, find us on Twitter. Feel free to reach out anytime. We're happy to help the community and any new users to Istio to overcome any areas they need clarification.
Absolutely. Yeah. Thanks again, everyone, for joining us.
Thanks.